So in this one, we're going to combine three parallel resistors now and find the total current since we know what our total voltage is. So this resistor is 2, this resistor is 5, this resistor is 10. Remember that in a parallel circuit, our resistors add up inversely. So I have 1 over my total equals 1 over R1 plus 1 over R2 plus 1 over R3. So I'm going to have 1 over RT is equal to 2, 1 over 2 plus 1 over 5 plus 1 over 10. Now remember, this is where you're going to use the x to the negative 1 button on your calculator. For me, it is this button here. It says x to the negative 1. Or some of your calculators might say 1 over x. You're going to use that button instead. So you're going to push the 2 button, push the x to the negative 1 button. So 2 x to the negative 1 plus 5 x to the negative 1 button plus 10 x to the negative 1 button. And then after that, you're going to hit the enter button. So you want to add all of those, or your answer button. Okay, now remember that that is still equal to 1 over RT, so we have to hit the x to the negative button one more time, and that gives us what our total resistance is, 1.25 ohms. Keeping in mind that, remember, in a parallel circuit, key idea that when we add our total resistors together, our total resistance is less than any one of the individual resistors. That's what makes it a parallel circuit. In a series circuit that we did over here, remember that when we add resistors together, our total resistance is greater than any of the individual resistors. So now that we have our total resistance here, now that we have our total voltage of 6 volts, we can find our current again by using Ohm's law, V equals I times R. 6 is our voltage, I is what we're looking for, our current, and we're going to replace our resistance with 1.25. So when I divide the 1.25 over to the other side, then I'm going to end up with a current of 4.8 amps. And that's what the total current is flowing through the battery at that time.